Hi everyone, hope you're doing okay. So this week we're going to be talking about something different. We're going to be looking at what are called the law of sines and the law of cosines. So today we're just going to focus on the law of sines, and then in the next video we'll discuss the law of cosines. So this is something that is part of the pre-calculus curriculum, but it's also something that appears on the SAT. I was helping a student a couple years ago prepare for the math SAT, and we were going through some practice questions, and this was something that was on there. And unless you have learned it before, you may not even realize what to do. So we're going to go to it right now. So up until this point this year, we've been looking at right triangles, and we have used the Pythagorean theorem and SOHCAHTOA. But now we're going to look at what you do if the triangle is not a right triangle. So if it is either an acute triangle or an obtuse triangle, that is called an oblique triangle, then you cannot use Pythagorean theorem or SOHCAHTOA. So that's why these other two methods are there. So you can solve or find parts of a triangle that is not right. Okay, so I left a space at the top of the page because I want you to draw in two diagrams. So an oblique triangle can be acute. So acute would mean that all three angles of the triangle are less than 90 degrees. So it would be something like this. Now the angles of the triangle will be labeled with capital letters. So say we have a capital A, a capital B, a capital C. Those will be the angles of the triangle. The sides are also labeled, and they use lowercase letters, and the way it works is that whatever is across from your angle A, you would call that the lowercase a or side A. Whatever's across from the capital B will be the lowercase b or side B, and then whatever's across from the capital C will be the lowercase c. So that's how you will typically see your triangles, with the angles as capital letters and the sides as lowercase letters. But it should be that the ones that match are opposite from each other. Now this is called an acute triangle because every angle is less than 90 degrees. This would also be true for obtuse triangles, so it may be like one angle is more than 90 degrees, so maybe something like that. And then you can still label it like ABC. The order doesn't matter, just as long as you label it. And then the lowercase a would be across from there, and then the lowercase c would be here, and then the lowercase b would be here. So in either of those two triangles, acute or obtuse, you cannot use the Pythagorean theorem, nor can you use SOHCAHTOA. Those are only things that you do for right triangles. Okay, so we're going to be looking at today what are called law of sines, and you would set it up according to proportions. So you will see proportions in about the middle of the page. You will see sine of A divided by A, sine of B divided by B, and sine of C divided by C. So remember, the capitals are the angles and the lowercase are the sides. Now you're not going to use all three proportions at once. You're going to use what you need in each problem. So for instance, you might only use those two and do A and B. You might only use these two with B and C, or you might use the A and the C, but not the B. So you're going to be setting it up as a typical proportion, not with three different things. Okay, so it's important to know when you use this method. So it depends on what you're given, and you'll see in the top of the page that there are bullet points. And notice these are things that you talked about in geometry a couple years ago. The A's represent angles and the S's represent sides. So if you have angle, angle side, or angle side angle, or side side angle, one of these three things, those are the first two bullet points, you're going to use the law of sines that I will show you today. Now the last two bullet points are what you would use in other cases, and that will be my next video. We're going to study these three today. Okay, so let's get to it. Going to number one, we are given two angles, B and C, and a side. Now notice that neither angle is more than 90 degrees, so that would be acute triangle. So just draw any acute triangle. And it doesn't really matter what order you put the A and the B and the C, just put them somewhere. And then we'll fill in whatever we're given. So it says that angle B is 64 degrees. Angle C is 38 degrees. And then side B is 9. So it has to be the one that's opposite from the angle B. So it would put the 9 down here. So what exactly do we have? We have two angles and a side. So we would call that angle, angle, side. The side that we're given is not in between the two angles, it's over here. So that's why it's angle, angle, side. So this is a time that it would be appropriate to use the law of sines. So we're going to do that right now. So we are going to be using one of the three proportions, two out of the three, I should say. So what you want to do is look for one of the letters that you have both pieces of. So notice that we have the angle B and we also have the side B. So I definitely want to use B in my proportion. So that would be the sine of 64 over 9. Okay, so notice I've got the angle C, but not the side C. So that's what I'm going to find next, is what is this piece over here. So I'm going to use the C's. So it would be the sine of 38 divided by little c, the lowercase c. Okay, so in middle school, probably you learned how to solve proportions by cross multiplication. So we're going to do that next. So I'm going to cross multiply diagonally. So I'll do the sine of 64 times c in one direction, and the other direction I'm going to do 9 times the sine of 38. Then I'm going to use a little algebra and divide both sides by sine of 64. And that will make c equal to this value right here. So you're going to need your calculator. This is something that you must have a calculator to do. So let's go to our graphing calculators. And before we get started, I want to remind you that there is a mode button on your calculator, and you need to pay attention to that anytime you're using trig values on a calculator. So if you go to mode, it's like the fourth one down on my calculator, you have the option of radian versus degree. You want to make sure that this is labeled as degree, because in the problem it had degree measurements. So if you keep it on radians, you're going to have every answer incorrect. So you don't want that. Change it to degree. Okay, so we're going to quit this, second quit, and put in what I circled on the note sheet. So it's going to be 9 sine 38, close the parentheses, put divided by, and then sine of 64, close parentheses, and press enter. So this is the answer that you should be getting, and as always, we're going to round to the thousands place unless we're told otherwise. So if I were to look at this, the 4 is in the thousands place, but that's followed by 8, so it would make it 6.165. So we're going to jot that down for the lowercase c over here. So fill that in. C is 6.165. And notice that there are units given in feet, so this would have to be in feet also. So the missing piece of our triangle is 6.165. Okay, we have to find all of the angles and all of the sides, so far we've only done one thing. So we've got to get this angle A next. Now this is something that you learned in geometry but may have forgotten about. There was a theorem that says that all three angles of a triangle must add up to 180 degrees. So using that fact, you'll be able to find this missing angle. So if you took 180 degrees and subtracted these two angles added together, so that would be 64 plus 38, you would be able to get what angle A is. So all I'm doing is adding these angles together, subtracting from 180. But you can put this all into the calculator at one time. So if you were to do that, you would find that angle A would be 78 degrees. So right here, put 78. Okay, so that's another answer we need. So we need one more thing in this problem. We need to find this side A. So we're going to do the law of sines one more time. So go back to what you were given. We had both pieces of B, so I'm going to use that. I could use C, but the problem with that is, remember, this one was rounded. So I don't want to put a rounded answer in there and then have to round it again. That would make it slightly off. So I'm going to go back to what I knew for sure, and that was the B. So you would set up another proportion and say that the sine of 64 over 9, those are the B's, would be the sine of 78 over A. So I want to know what the little a is. So I am going to cross multiply that. So that's going to be sine of 64 times A. And on the other side, 9 times the sine of 78. And then I will divide both sides by sine 64 and cancel those. So A will be whatever this value works out to be. So let's go to our calculator and find out. So remember, keep your calculator in degree mode today. Okay, so we are going to put what I just circled. So it was 9 sine 78, close the parentheses, divided by sine 64, and close the parentheses. So this one will be this answer. So rounded to the thousandths place, the 4 is followed by a 6, so that would make it 9.795. So jot that down for your last answer. So that will be the last thing we need for number 1, is that A is 9.795, and remember this was feet. Okay, so finally we have all the information that we need. So keep that in mind. You might want to stop and catch up if you didn't quite get all that. I know that was a lot in one problem. Okay, so we're going to move on to number 2. It's a similar question, but it will be slightly different, so don't tune me out yet. There's more to come. Okay, so for number 2, we have another acute triangle, and it doesn't really matter where you put the letters, just anywhere is fine. And then fill in the information that you know. So B is 61 degrees, C is 35 degrees, and we were also told that the side A is 8. So it has to be the side that's opposite from the capital A, so that would put the 8 over here. And then we have to do, well, first of all, we have to know what were we given. So I have an angle, 2 angles, but notice the side this time is in between the 2 angles. So we would call that angle, side, angle, the side being in between the angles. So this is another time to use the law of sines. Now this one is slightly different than the first one because I don't have both pieces of any of the letters. Notice I don't have both of the B's, I don't have both of the C's, and I don't even have both of the A's. So what I have to do is find this angle A first by remembering that rule from geometry that all 3 angles must add up to 180. So A will be 180 minus those 2 angles added together. So if you were to put that on your calculator, you would find that the answer is 84 degrees. So go ahead and fill in 84. Okay, so now we can go to the law of sines. We just had to do it in a different order. So we know both pieces of A now, so that's what I'm going to use. So I'm going to say the sine of 84 over 8 will be, and say I want to find B. So I know the angle B, but not the side B. So I'm going to say the sine of 61 over B. And then I will cross multiply, so that will be the sine of 84B on one side and 8 sine 61 on the other side. So then I will divide both sides by sine of 84. And B will be what you get if you put this into your calculator. So I'm not going to do that this time because I showed you that in the first example. So for this one, if I were to put that exact thing in the calculator and round it, I would get 7.035 millimeters. And then the last thing I have to find is the lowercase c, so that would be the side over here. I don't want to use this answer because it was rounded. It would be best to go back to the a's and say it's sine of 84 over 8 again, but this time we're going to use c. So sine of 35 over little c. Then I will cross multiply again, so I'll have sine of 84c equals 8 times the sine of 35. And then I will divide both sides by sine of 84. Those will cancel, so c will be equal to whatever I get if I type that exact thing into the calculator. So I'm not going to do it, but it works out to be rounded to 4.614 millimeters. So now we have all of the pieces that we were missing. So that completes number 2. Okay, 3 and 4 are different than those, so I know some of you are probably tempted to shut off the video and say, oh, I got this. Well, maybe not. So please stay with me a little bit longer. I'm trying to make this as short as possible. But this is something new to you. Okay, so this time we were given another triangle. Again, you can label it however you like. Let's see, we were given that A is 42 degrees. The side A is 22, that was inches. And also the side B is 12. So it would be set up like this. Okay, so what were we given? This time I don't have 2 angles, I only have 1, but I have 2 sides. So we would call this one side-side angle. The angle is not in between the 2, it is a different angle. So we call that side-side angle. So this is one more time that you can use the law of sines. Okay, so notice that I have both pieces of A, so I want to go ahead and set that up as sine of 42 over 22. And let's say we want to find angle B, because I do know what the side B is. I don't have the angle B, so I'll have to put capital B as my variable, and then 12 will be in the denominator. So the difference with this one is that we don't know the angle this time rather than a side. So I'm still going to cross multiply. Like one direction I would have 22 sine of B, and in the other direction I would have 12 times the sine of 42. So I'm going to divide both sides by 22, and that will be the sine of B. Okay, so this is what I want to put in the calculator, and this time I'm going to do it because it requires a little something different when we go to the calculator. So let's put this answer, or not the answer, but that work into the calculator. Okay, so I'm going to erase this so it doesn't get confused with the other problem. All right, so we are doing this time 12 sine 42, and we're dividing that answer by 22. And so here's our answer in the calculator. Ooh, I just pressed it twice. Okay, this is not the answer to the question because this is not B, this is the sine of B. So we don't have the angle B yet. So in the past, what we learned is that to find an angle, when we know what the sine is, we use the inverse sine or arc sine. So that's what will have to happen here. So I'm going to press second sine. Remember that symbol? That's read inverse sine or arc sine. And I want to put this last answer in. Now I don't want to round that answer because it'll be slightly off, and I don't want to type all that either because it's not even the full value. It cut off at some point. So what I want to use is the answer button. So press second and go down to the negative key way at the bottom. And I did not mean to put that little extra thing there, so delete it. So answer. So it should look like that, inverse sine answer. So what the calculator is doing is it's putting that entire thing in there for the value. You don't want to round it. Okay, so if I press enter, then here is what I would get. So my answer would be 21.406. 21.406. So that will represent the capital B. So one more time if you want to write this down. It was the arc sine or inverse sine of the answer, and that made B equal to, what was it? 21.406 degrees. So right up here I would get 21.406. Okay, notice now I don't have either piece of C. I don't have angle C nor side C. So I'm going to need to find the angle C first, and that would be done by remembering the fact that all three angles of a triangle must add up to 180. So I would do 180 minus 42 plus 21.406, and that will represent what capital C is. So if I were to put this all in the calculator just like it appears, I would get 116.594 after it was rounded, and that will be degrees. So that makes that angle right there 116.594 degrees. So we have to find one more thing, and that would be the side C over here. So we're going to need to do the law of sines once more. I don't want to use a rounded answer unless I absolutely have to. So I'm going to go back to the beginning and use the A's because I knew for sure what they were at the beginning. So that would be the sine of 42 over 22. And then I'm trying to find C. So even though this was a rounded answer, I have to use it in order to get the lowercase c. So it will be sine of 116.594 over C. I will still cross multiply, so that will be sine of 42 times C equals 22 times the sine of 116.594. And then I will divide both sides by sine of 42. And that will make C, the lowercase c, whatever this is when you put it into the calculator. So if you put in exactly that and rounded it, you would end up with 29.400. And this was measured in inches. Okay, so that's number 3 completed. Notice that that was different than the previous ones in that we had to do the arc sine over here. Okay, so one more problem and we'll be finished for today. And this one is even different yet, so still don't tune me out. I know the video is getting long, but I'm sorry. I'm trying to give you all the information that y'all need. Okay, so one more time. So this time we were given that A is 85 degrees, the lowercase a is 15, and the side B is 25. What are we given? We have a side, and an angle. So it's side, side, angle. The angle's not in between the two sides, it's over here, so it's side, side, angle. So this would be another time to use the law of sines. So we are given both parts of A, so that's what I'm going to use in my proportion. I'll say the sine of 85 over 15 would be, and this time I don't have the angle B again, so I'll put sine B over 25. Now this looks like the last problem, but trust me, it's not going to work out the same. I'm going to cross multiply again, so I'll have 15 times the sine of B, and this way I'll have 25 times the sine of 85. I will divide both sides by 15, and I'll have sine of b equals whatever this is when I put it in the calculator. Okay, so I'm going to go to the calculator now and show you that this one turns out differently than the other ones. So just bear with me a few more minutes and we'll be done. Okay, so if I go back to the calculator screen and I'm going to put in what I just found, which was 25 sine 85 divided by 15. Okay, so if I were to enter that, I would get 1.66 and so on. Now remember, that's not the answer, that's the sine of b, it's not actually b. So I would need to do the inverse sine, or the arc sine. So I'm going to do arc sine of that answer. And notice that I get this. So notice it says error domain. So when we studied inverses earlier this year, we learned that sine and cosine, when you do the inverses, their domain has to be between -1 and 1. So the reason why we're getting this error is because if we go back to the problem, pick go to, that answer that we had gotten before, it's gone now, but it was like 1.66 something. So that was more than 1. So the domain has to fall between -1 and 1 when you do inverse sine and inverse cosine. So that's why that is happening. The number we got was not in the domain for inverse sine. So what does that mean for this problem? Well, when we did the inverse sine of that answer, remember it gave us an error domain. So that happens sometimes, and when it does, it means that this triangle that we were asked to look at does not exist. So what does that mean? It doesn't exist. It's right here, right? Well, actually, what it means is that it could not possibly match the measurements that were given in the problem. Like if you were to actually get some material and measure out 25, whatever it was, inches, miles, or whatever, of the material on one side, and 15 inches or miles, whatever it was, on the other side, and you actually tried to construct a triangle, and you got out a protractor and found that angle to be 85, you would find that it would not form a triangle. So what could possibly happen is you might have like one side here, maybe this is 85, but maybe this piece would be too short to make the triangle. And maybe this was 25 and that was 15. So that's a possibility. Or it could be that this piece is too long and it would go like way over here. So one of those two things is happening. Either it's too short or too long to make an actual triangle. So that's what I mean by this triangle does not exist. And that will happen on occasion. All right, y'all. So go ahead and do the assignment as usual. I'm only giving you till tomorrow to get this done. So please don't wait till the last minute. Let's get it done on time because Wednesday we're going to be looking at another lesson called the Law of Cosines. So I'll talk to you soon. Love you guys. Bye-bye.